ever wonder why two cuts with the exact same tool can produce completely different results? Sometimes the answer isn't the tool or the machine or even the material. It's how you adjust your feed rate along the tool path. Getting this balance right can be the difference between chatter and perfection, between tool wear and tool life. Let's dive into how feed adjustments and chip thinning work together to keep your machining process consistent, efficient, and smooth. When you're running a straight linear tool path, chip thinning only applies under certain conditions. If you're cutting at a full width of cut, chip thinning doesn't even apply. At half the cutter's width, it still doesn't apply. But once your radial width of cut drops below half the tool's diameter, that's when chip thinning comes into play. And that's your cue to increase the feed rate to maintain proper chip load. That increase keeps your tool cutting efficiently without rubbing or overloading. Now, we often think about feed rate in terms of how fast can I go? But there are times when you actually need to slow things down. I can't believe I just said that. It tasted bad coming out of my mouth. But doing so at the right moment is just as important. A perfect example is during circular interpolation, both internal and external. When your tool path follows a curve instead of a straight line, the effective engagement angle between the tool and the material changes. So should your feed rate. For internal circular cuts, you'll want to decrease the feed. For external cuts, you'll increase the feed. This adjustment is based on the ratio between the diameter of the tool and the diameter that you're machining. The closer the diameter of the feature is to the diameter of the tool, the greater the engagement angle. So you should reduce your feed or select a smaller diameter tool to minimize the effect. Large external curves reduce engagement, so let it eat. Making these adjustments at the right time does more than just control speed. It equalizes tool pressure and heat across the entire process. And when the tool pressure is balanced, everything gets better. Tool life increases, chatter decreases, and you have a more consistent surface finish. Let's walk through a real-world example. You're using a 3/4 inch end mill set up with an intended chip thickness of 5/1000 feet per tooth for your straight line linear cut. That's your baseline, your starting point. As your tool path moves into a 2-inch internal radius, the effective chip thickness increases because of the curvature. To compensate, you'll need to decrease your feed per tooth to around 3/1000. Now, as the path moves outward to a 2-inch external radius, the opposite happens. The effective chip thickness decreases, meaning you can safely increase your feed per tooth to about 7/1000. These subtle but deliberate changes are what keep tool engagement and chip load consistent across the entire cut. When you adjust feeds like this, not just based on speed, but on geometry, you achieve a more stable, predictable process. Your tools last longer, your parts come out cleaner, and your machine runs smoother. So remember, feed adjustment isn't just about how fast you can go, it's about how smart you cut. As always, if you like the content, please like, share, and subscribe, and look for new videos each week with more performance tooling secrets.